Hello students, Standard 8, Chapter number 11, Mensuration. In this chapter, in the last few videos, we recalled our memories that we learned in the lower standards. That was the perimeter and the area of some plane figures like the squares, rectangles, circle, triangle, etc. And also we find the perimeters of some figures which are combined figures. So it was easier, but now we have to learn about the areas of some special figures like a trapezium, a quadrilateral, normal quadrilateral, and then the parallelograms or the other different figures. Sometimes we have to divide the figures into parts to find the area of that combined figure. So let us start with the area of a trapezium. You know that what is the trapezium? Trapezium is a quadrilateral in which only one pair of opposite sides is parallel. So when one pair of opposite sides is parallel in a quadrilateral, it is known as a trapezium. Here ABCD is a quadrilateral in which line segment AB is parallel to CD. So it is a trapezium. Now here AM is the perpendicular distance between these two parallel lines. And then the length of the side AB is A and length of the side CD is B. So now the trapezium can be divided into three parts also. Like if you draw here also, then you see that there is two triangles and one rectangle. So if you find the area of these three separate parts, with two triangles and a rectangle between them, and if you add them, you will get the area of the trapezium. But to do that, it will take a long time, because we have to find the areas of two triangles, we have to find the area of the rectangle, and then we have to add all these three areas. Then we get the area of a trapezium. But if we use the direct formula, then it will be easier to find out the area of the trapezium. So you should keep this formula in the mind, so that within a few seconds or within a minute or two, you will be able to find out the area of the trapezium. So the formula is that area of trapezium is equal to 1 by 2 multiplied by height multiplied by sum of parallel sides. Here height is h, parallel sides value are a plus b. So it is h upon 2 into bracket a plus b. It means that what are the requirements? If you want to find the area of the trapezium, the required things are, first, the length of these parallel sides. We must be familiar with the length of the two parallel sides. So, AB and CD are parallel lines. So, we have to know the length of these parallel sides. Second thing, a perpendicular distance between these two lines. Not any distance. You can't find this distance. You can't find this distance. It must be perpendicular distance, because that is the shortest distance. So you must draw a perpendicular either from this one, or you can, same it will be. So any one height must be known. So now the product of half, then height, and the sum of the parallel lines, that will give you the area of the trapezium. So to find the area of a trapezium, as I told you, we need to know the lengths of parallel sides. First requirement is lengths of the parallel sides, and second one, and the perpendicular distance between these two parallel sides. Between those two parallel sides, what is the perpendicular distance? Means exactly at 90 degree we have to draw it, and then find the length of that perpendicular distance, which is also known as height. So when you find it, then the half the product of the sum of lengths of parallel sides and the perpendicular distance between them gives the area of it. So I hope it is clear in your mind. You have to remember this formula for the future use also. That area of trapezium is equal to 1 by 2 multiplied by height into bracket sum of its parallel sides. Let us understand with the example in the try this. First one, find the area of following trapeziums. Find the areas of following trapeziums. First one, there is 7 centimeter, the height 3 centimeter, and the other side is 9 centimeter. So now first check what are the requirements. Parallel sides. So the length of parallel sides is given, and the distance between the parallel side is also given. So now area of trapezium is equal to half into h into bracket sum of parallel sides. So is equal to half into h is 3 into 7 plus 9. That is half into 3 into 9 plus 7, 16. 2 8s are, so 8 3s are 24 centimeters square. So it is, calculations are very simple. Just you should know the formula. That area of trapezium is equal to half into height into bracket sum of parallel sides. The second one is also trapezium, but it is drawn a different way. and the height is like that, 6 centimeter, that is 5 centimeter, and the long side is 10 centimeter. So here also area of trapezium is equal to half h sum of parallel sides. Here height is this one, 6 centimeter, and sum of parallel sides, so that is 10 centimeter plus 5. Here 2 3 are 6, so 3 multiplied by 15, that is 45 centimeters square. So if you know the formula, if you know the sides which are parallel and the height, then by using this formula, easily we can find the area of any trapezium. Now, area of any general quadrilateral means not a special type. It can be used for any type of quadrilateral. So now, here what we are going to do, we know that when we draw any one of the diagonals in a quadrilateral, then we can split that quadrilateral into two triangles. Look here, when we have a quadrilateral and we join that diagonal, then two triangles are made. So by splitting them into two triangles, it is easier to find the formula for the any general quadrilateral. So here you can see that ABCD is a quadrilateral in which AC is the diagonal, and H1 is the height of the triangle ABC, H2 is the height of triangle ADC. Because we know that area of triangle is half into base multiplied by height. So here we draw the heights on the diagonal AC. For both the triangle, we took the common base as AC. And therefore, we draw that two heights, two perpendiculars on the AC from the points B and point D. So here you can see that the height H1 is here and the height H2 is here. So now, what is the area of the quadrilateral ABCD? Area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ADC. Means we have to add the areas of both the triangles. So now area of triangle ABC is half into base AC into H1. Half into AC into H1 plus similarly area of triangle ADC is equal to half into AC plus into H2. So now half into AC we can take out common, then what is remaining? H1 plus H2. So half into AC into bracket H1 plus H2. Here AC is the diagonal, so we can replace it by D. So we get the formula half into D bracket H1 plus H2. So that is the formula to find the area of any general quadrilateral. What is that? That is half into D bracket H1 plus H2, where D stands for the length of the diagonal. Let us understand with an example here. Example. Find the area of quadrilateral PQRS shown in figure. 2.5 centimeter. That one is 5.5 centimeter. And that one is 1.5 centimeter. P, Q, R, S. So here, for quadrilateral PQRS, what is D? Diagonal. Diagonal is 5.5 centimeter. What is H1? H1 is 2.5 centimeter. And what is H2? 1.5 centimeter. Now we have to use the formula. So area of quadrilateral PQRS is equal to half into D, H1 plus H2. What is D here? 5.5 into bracket 2.5 plus 1.5. So that is half 5.5 into 2.5 plus 1.5 is 4, because 2.5, 1.5, 5 plus 5, 10, carry 1, 2 plus 1 plus 1, 4.0 means 4. So now 2 2s are 4. So 5.5 multiplied by 2, 2 5s are 10, 2 5s are 10 plus 1, 11.0. So 11 centimeters square. So that's the way we can find the area of any general quadrilateral. So we learned today two new formulas. What did we learn today? First we learned the area of a trapezium. And what is the formula for it? Half into height between the parallel lines multiplied by sum of its parallel sides. And second, we learn the area of any general quadrilateral. For that, we need to know the diagonal and the two heights. So half into D into bracket H1 plus H2, where D is the length of that diagonal and H1 and H2 are the heights that are drawn on the diagonal. So here we are going to finish the session. Will be followed by PDF. Any confusion, write down in the comment section. Thank you very much.